Hi everybody, so this video is about Gaussian reduction. This is the first of a two-part video about this section. Okay, so the first thing we're going to do is just talk about what it means to have a linear equation with three variables. Okay, so you'll see that this is pretty much the same as standard form for an equation with two variables, right? Ax plus by equals c. Okay, but instead now we have a third variable z, and our constant term is called d. Okay, so a, b, c, and d are numbers, and then our variables are x, y, and z. Okay, so let's look at what a solution to this would look like. Okay, so you'll notice that this is really similar to the definition for a solution to a linear equation with two variables. Okay, it is still something that when you substitute it gives a true statement. Okay, but instead of having an ordered pair xy, we have what's called an ordered triple xyz. Okay, so let's look at an example. Okay, and we're going to ask the question, is this a solution? Okay, so what we're going to do is substitute this in for each one of these equations and check. Okay, so first, right, so this is a system of three equations with three variables. Okay, and that should look similar from in the other stuff in this section we had systems of two equations. Okay, so we're going to plug in this candidate solution and see if this is giving us a true statement. Okay, so this is -8 plus 12. Okay. Oh, I'm sorry, plus 6. So -8 plus 6 is -2, plus 20 is 18. Okay, so we would have that that's a true statement. Okay. Then let's look at our second equation. Okay, we're remembering that to be the solution to a system, it has to be a solution to each equation in that system. Okay, so 3 times -4 is -12, plus 8 is -4, plus 5 is 1. Okay, so that's a true statement as well. Okay, and then we'll plug it into the very last equation, the one that you can see here. Okay, so -4 plus 2 is -2, plus 15 is 13. Okay, so you'll see that this is also a true statement. Okay, so when you substitute into each one of these equations, you get a true statement for each one. So is this a solution? Yes. Okay. All right, let's look at part B. Okay, so we're going to use the same method of plugging in this point to the different equations. Okay, so we're going to start with the first equation, which is 2x plus 3y plus 4z equals 18. Okay, so 2 times 5 is 10, plus 0 plus 8, that is 18. Okay, so it's certainly a solution for that first equation. Now let's check the second equation. Right, which was 3x plus 4y plus z equals 1. Okay, so 3 times 5 is 15, 0 plus 0 plus 2. Okay, so 15 plus 2 is 17. Okay, so this is going to be false. And when we get a false answer, right, obviously 17 is not equal to 1, we can say right away that this is not a solution. Okay, we don't need to check the third equation, because if this is not true for any of them, then it's not a solution for the system. Okay, so this is not a solution, even though it is a solution for that first equation. Okay, all right. Now, let's look at our first method to solve systems of 3 equations with 3 variables. Okay, so that was how you could check your solutions. So this is our first method to solve. Okay, now we're not going to solve graphically, because when you graph these, they're 3-dimensional, and it's very difficult to graph accurately in 3 dimensions. Okay, so our first method is going to be analogous to the substitution method. Okay. This method is called back substitution. Okay. So here's the first step. The first step is to solve for one of the variables in one equation. Okay. Now that's exactly the same first step that you see in the substitution method that we talked about in the previous section. Okay. Now in this instance, when I say solve for one of the variables, I mean solve for a numerical value for that variable, as opposed to in substitution, you really mean isolate that variable. Okay. Once you do that, you are going to substitute that value into the second equation. Okay, so you're taking the value that you found in part 1 and you're substituting it into part 2, and then you're going to use that to solve for a second variable. Okay. Now you have the values for 2 of the 3 variables, so you're going to substitute in both values. Okay. And then the last thing that we're going to do in terms of solving is we're going to solve for the last variable. Okay. Now, really the last thing you're going to do is write your answer as an ordered triple. Okay. So just like in the previous section, we were writing our answer as either an ordered pair or x equals y equals. Okay, here we're going to write our answer as an ordered triple or as x equals y equals z equals, like that. Okay? All right. So let's go ahead and look at an example of this solving method. Okay. Okay. So this is characteristic of what you'll see when you're able to use back substitution, is you'll see that one equation only has one variable, one equation has 2 variables, and one equation has 3 variables. Okay, so this is really the setup that you need to use back substitution. Okay, so the first thing I'm going to do is take this equation that only has one variable, and I'm going to solve for that variable. Okay, so I'm going to divide both sides by 13. And I'm going to get z equals -1. Okay, so that's my first step. Then the second thing I'm going to do is I'm going to take that value and I'm going to substitute it into my second equation. Okay, so I have 3y plus 5z, right? And now we know z is -1 equals -8. Okay. So now I'm going to solve this equation for y, okay? Okay, add 5 to both sides and divide by 3. Okay, and I get that y is also -1. Okay, then the last thing I'm going to do is substitute both of those values, okay, into my third equation, this one here. Okay, so I'll have 2x minus y minus z equals 6. Okay, right, this will be +1 and +1. Okay, so I'm going to subtract 6 from both sides and then divide both sides by 2. Okay. And now the last thing I'm going to do is write my answer as an ordered triple x, y, z. Okay, so x, y, z. Okay. All right, so that's how you use back substitution. Let's do one more example of that. Okay, so we're going to solve this system, and you can see that this has the same setup as the previous example, okay, where we had one equation that only has one variable, one that has two, and one that has three, okay? So the first thing I'm going to do is solve this last equation for the variable y, okay? Right, I'm dividing both sides by -4, okay? Now I'm going to plug that value into this equation that only has two variables. So 3y plus z equals 5. Okay. So this gives me z equals 11. Okay. And now I'm going to substitute both of those values into my third equation. Okay. So I had x plus y plus z equals 2. Okay. So -2 plus 11 is 9. So this gives me x equals -7. Okay. And now I'm going to order my answer, x, y, z. Okay. All right. Now, the benefits of this back substitution method are that it's really easy and pretty quick, okay? The unfortunate part about this is that it doesn't often work. You really have to have this setup where you have 3, 2, 1, okay? Otherwise, it's almost impossible to use back substitution to solve, okay? So let's talk about a method that works more often, okay? But it's also a little bit longer process. Okay, so that's the title of the section. Okay. Gaussian reduction. Okay, the guy that invented this method was called Gauss. That was his last name. And the method is named after him. It's called Gaussian reduction. Okay, so the first thing we're going to do, this is largely based on the method that you see when you have two equations where that's called elimination or combinations. Okay, it's very similar to that. Okay, so the first thing you're going to do is select a pair of equations okay, and eliminate one variable. Okay, so here you are using combinations, okay, or elimination, whatever you want to call it. Okay, so that using that method, okay, you're eliminating one of the three variables. Okay, then the second step, okay, is to select a different pair of equations and eliminate the same variable. Okay. It is very important that you eliminate the same variable that you did in step 1. If you don't, you're not actually making any progress here, right? It's not wrong, but it's not helping you in any way. Okay. So then in step 3, okay, you'll see this in the example, but for now I'm just going to state this, okay? Okay, so you now have two equations with two variables, and you are just going to solve that. Okay, so you would solve it algebraically, okay, using either combinations or substitution. Okay, then we're going to substitute those values okay, into one of our original equations. Okay. And that's going to allow us to solve for the last variable. Okay. And then just like the previous method, our last step is going to be to write our answer as an ordered triple. Okay. All right. So let's see this method in action. Okay, so the directions just say solve. Okay. Now you can see that this is a little bit different than the previous examples because all three equations contain each of the variables. Okay, so this method is more general. You can use it for any system and it doesn't have to have that 3-2-1 setup that you need for back substitution. Okay, so now I'm looking to use elimination to eliminate one of the variables. Okay, now I could multiply this by -2 and eliminate x. I could multiply this by -3 and eliminate x here. I could multiply this by 2 and eliminate y, multiply it by 3 and eliminate y, -3 and eliminate y. Could multiply this by 2 and eliminate z, or multiply it by 3 and eliminate z. Okay, so in terms of choosing a variable to eliminate, there's nothing here that would be too difficult to do. Okay, so we're just going to eliminate x, but that's largely just a choice. Okay. In general, you want to choose something that's going to be easy to eliminate, but here, really any of them would be easy. Okay. So I'm going to number my equations really quick. Okay. So if I want to eliminate x, okay, I'm going to just pick the first two equations. Okay. So I'm going to use equations 1 and 2, and I'm going to eliminate x. So I'm going to take my first equation and I'm going to multiply it by -2. Okay, just like you do in combinations. So I'll get -2x plus 4y -2z equals 2. Okay, so I'm just multiplying the entire first equation by -2. Okay, and then I'm just going to copy my second equation. So I have 2x plus y minus 3z equals 3. Okay, and just like you do in combinations, you add them together. Okay, so -2x plus 2x is 0. That was the point. 4y plus y is 5y. Okay, and then -2z minus 3z is -5z. Okay, and then 2 plus 3 is 5. Okay. All right. So now that's my step 1, and I'm going to name this equation 4. Okay, you can see it's not something that you can solve because it still has two variables. That's always the way it will be. Okay, we're just moving on. Okay, so now we're going to do step 2, and we're going to pick two other equations to eliminate the variable x. Okay, we still have to do eliminate x, but now we're just going to not pick 1 and 2, okay? So we can either pick 1 and 3 or 2 and 3, okay? Now if you go to eliminate 1 and 3, we could just multiply this by -3, okay? So that's pretty easy. If we want to eliminate these two, we have to multiply this one by 3 and this one by 2, right? So that's a little bit more difficult. So we're going to eliminate using 1 and 3. Okay. So I'll let you peek at the equations again. Okay. So I'm going to take equation 1 and I'm going to multiply it by -3. Okay. So I'll have -3x plus 6y, okay, minus 3z equals 3. Okay, and then I'm just going to copy down my third equation. Okay, and just like you do in combinations, this is really combinations, but just like you do in combinations with two equations, you just add them. So -3x plus 3x is 0 as intended. 6y plus 3y is 9y. Okay, -3z minus 2z is -5z. Okay, and 10 plus 3 is 13. Okay. All right, and we're going to name this equation 5. Okay, so now you can see with equation 4 and 5, we do have two totally new equations, and they do have only two variables. Okay, so I am going to solve this new system of equations. Okay, so the first thing I'm going to do is just copy down my equations. Okay, so equation 4 was 5y minus 5z equals 5. Okay, and equation 5 was 9y minus 5z equals 13. Okay, so you can see this is going to be pretty easy for combinations. So I'm just going to multiply the top one by -1, and I'm just going to copy the second one. Okay, now -5y plus 9y is 4y. Okay, 5z plus -5z is 0. 13 minus 5 is 8. Okay, so I can finish solving this by saying y is 2. Okay, now that I have the value for y, I can plug back in here to 4 or 5 to find the value of z. Okay, so I'm just going to plug into equation 4. Okay, so I have 5y minus 5z equals 5. Okay, so I'm going to subtract 10 from both sides and then divide both sides by -5. Okay. Okay. So now I have two of the variable values, right? I have y equals 2 and z equals 1. Okay. So this brings us to the very last step, where you take those values and plug them into one of the original equations. Okay, so I'm just going to use our very first equation, equation 1, okay, which hopefully you'll remember was x minus 2y plus z equals -1. Okay, so this is just equation 1 from the very beginning of the problem, okay, with y plugged in as 2 and z plugged in as 1. Okay, so this is -4 plus 1, which is going to be -3. Okay, and this gives me x equals 2. Okay, So I'm going to write my ordered triple. X is 2, Y is 2, Z is 1. Okay. All right. Now, like I said, this process isn't really more complicated than the regular combinations process. It's just more time consuming because you have to do it more, right? So you have to do it 3 different times versus 1 time for actual combinations method. Okay, so let's look at another example of this. Okay, so again, we have to pick a variable to eliminate, and we need to pick a way to do that, right? We need to pick a pair of equations. Okay, so the very first thing I'm going to do is look for which variable seems easiest to eliminate. Okay, so to me, none of them are particularly difficult. But I think Y, because you have ones that are already opposites, and Z, because you have ones that are already opposites, are a slightly better choice than X. Okay, so let's eliminate Y. Okay, and the obvious choice, I'm just going to label my equations, is to use 2 and 3 because these two are already opposites. Okay? All right, so I'm just going to copy those 2 equations down. 2x minus y plus 2z equals 6. Okay? And then 3x plus y minus z equals 5. Okay? And I'm going to add them together. So 2x plus 3x is 5x. Y, negative y plus y is 0. That's what we wanted. Okay, and then I have 2z minus z is 1z. 6 plus 5 is 11. Okay, so you can see we're left now with x and z as our variables, and this is going to be our equation 4. Okay, all right, so now we're going to do the same thing again. We're still going to eliminate y. Okay, but we have to choose a different pair of equations. So we're going to look at these and say, okay, which one would be easiest to eliminate? Now, it doesn't really matter. Here we could multiply by -2. Here we could just multiply by 2. But the difficulty level is really still the same. Okay, so let's choose 1 and 2. Okay, so I'm going to take my first equation and I'm just going to copy it. Right, if we're looking at these 1 and 2, right, I want this to be 2 and -2. This is fine. I'm going to multiply this one by 2. Okay, so I'm just going to take my first equation and copy it down. Okay, and I'm going to take my second equation and multiply it by 2. Okay, so that would give me 4x minus 2y plus 4z equals 12. Okay, now I'm going to add x plus 4x is 5x. Okay, z plus 4z is 5z. Okay, 3 plus 12 is 15. Okay, and this is going to be my equation 5. Okay, so you can see our 2 equations here. Okay, now if we're going to do elimination, we have 5x and 5x, so we might as well just multiply one of them by -1. Okay. So what I'm going to do now is I'm going to copy down my two equations. Okay, so this is equation 4. Okay, and here's my equation 5. Okay, so now I'm going to try to do elimination. So I'm just going to multiply one of them by -1. Okay, and then my second one, I'm just going to copy it. Okay, now I'm going to add these together. -5x plus 5x is 0. -z plus 5z is 4z. Okay, and -11 plus 15 is 4. Okay, so this lets me get the value for z, right, where z is 1. Okay, now I'm going to plug this into either one of these two equations to get the value for x. Okay, so if I plug into equation 4, I would have 5x plus z, okay, equals 11. Okay, so when I subtract 1 from both sides and then divide by 5, I would get that x is 2. Okay, now our very last step, okay, is I have the value for x and I have the value for z. Okay, I'm going to pick one of my very original equations from the very beginning of the problem and solve for y. Okay, now I can see that y is alone in this equation, so I'm going to choose that one. Okay, so I'm going to choose equation 3, okay, which was 3x plus y minus z equals 5. Okay, so 3x plus y minus z is 5. Okay, and now I'm going to solve for y. So 6 minus 1 is 5. Okay, and this gives me y equals 0. Okay, so now I'm going to look at my ordered triple, x, y, z. Okay. All right. When you're doing these, I really recommend that you stay organized and you just go step by step. Okay, we will do maybe one more example in the next video, so if you feel like you need more examples, go ahead and watch that. And we'll also do some application problems. So I'll see you guys soon.